All right, so welcome to this lesson on 2-1. We're going to be talking about the relationship between two categorical variables. So the essential question is, how can we visualize as well as determine if there's an association between two categorical variables? And for our goals today, we want to be able to distinguish between explanatory and response variables for categorical data. We want to make a segmented bar chart to display the relationship between the two variables. And we want to determine if there's an association between two categorical variables and describe the association if it exists. So we're going to be talking about response variables, explanatory variables, and compare those two. We're going to talk about how to make segmented bar charts, and we're going to talk about association, how to determine that. All right, so in Chapter 1, we learned how to display the distribution of a single categorical variable, and we used, pie charts, bar charts to display those. Remember that a categorical variable displays like groups or categories, right? So categorical variables are like groups or categories. And like in Chapter 1, we did one categorical variable. And in order to do that, we used the pie chart, bar chart. So for example, categorical variable like, blood type or something like that, that is a category or a group. So now we're going to put two variables. We're going to analyze two variables and their relationship to each other. So usually we have names for these variables. So we call them response variable and explanatory variable. So a response variable measures the outcome of a study. You can usually liken a response variable to like a dependent variable. So this is kind of like, for example, the dependent variable. Okay, so it is, the outcome that is measured. And then the explanatory variable, it's the one that is kind of manipulated, or, is the one that explains the changes in the response variable. So you can kind of liken this to the independent variable, just to kind of give you a rough idea of what those two mean. All right, so we want to be able to determine like what is the response variable or what is the explanatory variable given like a study. So we want to identify for the following relationships. So the first part is opinion about tax reform and political party membership. So in this case, the explanatory variable is whatever can explain the change in the outcome. So the explanatory variable is the political party membership, because knowing the political party will help predict the person's opinion about tax reform. Okay, so for part A, the explanatory variable is political party membership. And we said because knowing the party, the political party, will help predict the other variable. In this case, the other variable is, the opinion about tax reform. So, and in this case, the response variable is the outcome of the opinion about tax reform. All right. So for part B, they're talking about anger level, low, moderate, or high, and whether or not a person has coronary heart disease. So in this case, the explanatory variable would be the anger level, because that will ideally help us. It might explain whether or not someone develops coronary heart disease. We don't know if it actually does explain if there's an association, but we do know that the anger level, if we were to study this, then the anger level would be the explanatory variable. Okay. And then the response variable is the outcome. So depending on the anger level, there'll be some kind of outcome of whether or not they develop. So the response variable is the occurrence of coronary heart disease. Okay, so now we know how to determine the explanatory variable versus the response variable. Okay, so now in some relationships there isn't a clear explanatory or response variable. So there isn't always going to be clear cut. So for example, I'll give you an example, would be eye color and hair color. Right, so eye color and hair color. So in this case, the eye color and hair color, none of the variables could be used to predict or explain the other. So there isn't a clear-cut, explanatory variable. After identifying the explanatory variable, in order to analyze the set of two variables, we want to display the distribution of the response variable for each of the categories for the explanatory variable. So we could do this with the side-by-side bar charts that we learned from lesson 1.2, or we can use a new bar chart type called segmented bar charts. And these are kind of like stacked bar charts. So a segmented bar chart displays the possible values of the categorical variable as segments of a rectangle that kind of stack on top of each other. The area of each segment is proportional to the percent of individuals in that category. So if we were to talk about, for example, the survey of 200 students on which superpower they preferred based on their gender type, in this case, well, gender is going to be the explanatory variable, because gender could help us explain whether which superpower the students preferred. So the explanatory variable in this case is gender, and then the response variable that is measured is which superpower was preferred. So the preference of superpower. Okay, so if we were to graph the results and collect the data for 200 students, this one on the left side is the side to side or side by side bar chart. So this is the side by side bar chart. And it literally is showing the bars are side by side so that you can compare how many females preferred a certain superpower versus a male. So we can use that to compare the two distributions categorically, or we can use a segmented bar chart, which is what we're going to focus on today, which is on the right side. So notice it looks like a stacked plot, where you have the different categories stacked on top of each other. And you're always going to have each bar representing 100%, and then you're going to break that bar into the mini percentages for each category per gender in this case. All right. So how do we make this segmented bar chart? So we're going to talk about an example. In 1912, the luxury liner Titanic, on its first voyage across the Atlantic, struck an iceberg and sank. Some passengers got off the ship in lifeboats, but many died. The two-way table gives information about adult passengers who survived and who died by class of travel. Make a segmented bar chart to display the relationship between survival status and class of travel for passengers on the Titanic. So here's our two-way. This is called a two-way table. A two-way table shows you, it's a table that shows you two categories, one on each side with data to join the two. So the first problem wants us to identify the variables. We want to actually, make the bar chart. So the first step to making a bar chart, identify the variables that are involved. Which one is explanatory, which one is response. All right, so in this case, the explanatory, so let's look at the explanatory variable. The explanatory variable is what is going to help us predict something, right? So the explanatory variable is the class of travel, and then that will help us predict whether they survive or not. So the explanatory variable is the class of travel, and then the response variable is did they survive. And we'll say survival, or we'll just say survival status. We'll say that, survival status, just to kind of give it a name. Survival status, whether they survived or not. Okay, so now draw and label the axes. And then we're going to put the explanatory variable on the x-axis and the response variable on the y-axis. Okay, so the name of the explanatory variable under the horizontal. So in this case, we said that class of travel is our x-axis. According to the two-way table, we have first class, second class passengers, and third class passengers. Pretty straightforward so far. And on the vertical axis, we start at 0%. And so we're going to label this percent. Okay, so we're going to be calculating the percents for each of these. Okay, so if we look at the scale, we're going to scale this by, let's just say we go by 20s. All right, so we set up step 2 and step 3. So scale the axes and draw and label the axes. Step 4, draw 100% bars above each of the category names for the explanatory variable on the horizontal axis, so each bar ends at the top of the graph. Make bars equal in width and leave gaps between them. Okay, so draw the 100% bars above each of the names, and then make the bars equal in width. Okay, so we're going to be drawing 100% bars for each of the categories, kind of like this. Make them about the same width and the same distance apart. And they're both at the 100% mark. Okay, pretty easy fourth step. Now, the fifth step, segment each of the bars. So for each category of the explanatory variable, calculate the relative frequency for each category of the response variable. So basically calculate the percents. Divide the bar so that the area of each segment corresponds to the percent of individuals in that category. So this is where we actually find the percents and then we label them. So include a key that identifies the different categories of the response variable. Okay, so now we have our 100% bar chart, so we need to calculate the percentages here. So using the table, right, we're going to calculate the percentage of people who survived in first class. Okay, so if we look at first class, 197 out of 219 survived. Okay, so we're going to be using the results from that table. Okay, so survived. For first class is going to be 197 out of 319 first class people, which is 62%. And then this means that 38% did not survive. Okay, so died by first class, that means 38% did not survive. And then for survived second class, there were 94 people who survived out of 261, which is 36% survival. Which means 64% died. And then for the third, 151 out of 627 survived, and that would be a 24% survival rate. Which means that 76% did not make it. All right, so now we got the percentages. We're going to estimate, the percentages from this, and we got to determine, well, what we're going to use for, what color or, are we going to use for surviving versus dying. So let's just say that surviving is going to be in blue. Okay, so we're going to make a key out of this basically. So we'll say so red means died. And blue is survived. So that's our key. Okay, so if we were talking about surviving, we have 62%, so that's around here. Survived. And the rest did not make it. For survival for here is about 36%. And then the last one was 24%. All right, so now we can kind of tell from the graph, right? If we look at the graph, it seems that, if you're first class, you have a lower rate, you have a higher rate of survival, and then as you're, proceed to second class and third class, you have a lower rate of survival and a higher rate of death. So there's some kind of relationship here. And we call this relationship association, right? So this is where we can actually compare the two. So once we make a graph, we have to determine whether there's an association or a relationship between the two variables. So an association is between two variables is if knowing the value of one variable helps us predict the value of the other variable. So if it does not help us predict the value of the other variable, then there is no association between the variables. So again, looking at our superpower example, if we were in this original example, so this is the original example, it seems that there's an association between gender and their preference of the superpower, because it seems that knowing their gender helps us predict which one they prefer. So for example, males seem to much more likely prefer freezing time or super strength. So if you look at the males, they have a higher proportion of freezing time and a higher proportion of super strength in relative to their female counterparts, right? So now what if there is no association? So this is another example. So this is the modified example of the original. So let's say we get these results for 200 individuals. In this case, there appears to be no association between gender and superpower preference, because knowing a person's gender will not help us predict the superpower they prefer. Notice that they're equivalent for each category. So this is not going to help us predict, based on gender type. So since they're equal in their preference. Okay, so using the same problem that we, did earlier, is there an association between survival status and class of travel? Well, we kind of already mentioned this, right? So, and they want us to explain our reasoning. So, in this case, we said that there is an association. There seems to be some kind of, relationship between those two things. So there is an association between survival status and class of travel. Okay, so let's see why is there an association? Well, the association is that passengers in the first class were the most likely to survive. And third class passengers were the least likely. So if I were to give you, new data, right, from 200 other people, and I were to give you the percentages of survival status, you could ideally use these percentages to predict which, rather, if I gave you, the amounts, right, you can kind of tell which class they're in based on the response you get, right, based on the percentage survival status. So, if it's a high survival status, it's probably belonging to someone in the first class. So therefore, there is some kind of association. Now, note that association does not imply causation. So just because two variables are related doesn't mean that one caused the other. So in the case of the Titanic, just because there's a relationship between class travel and survival status, it doesn't necessarily mean that if you were first class, that caused your higher survival rates. Okay, there could be other variables that are involved. So for example, So I'll give you an example of this. So if we're talking about so a recent study claimed that people who are overweight are less likely to die within a few years than people of normal weight. Okay, so that people that are overweight less likely to die than those that are not overweight. Okay, so at this point you might be thinking, well, how did they come to this conclusion? Where's the data? How did they do the study, right? These are kind of things that you want to kind of keep in mind, and you want to, keep a wary eye on, like, how did they do this study? So it turns out, the study included smokers. So people that were overweight were not smokers, right? In this case, in this example, the overweight people were non-smokers in the study. And they were being compared to smokers. And so smoking increases the death rate, right? So it made those that were overweight and non-smokers look better. So you know that smokers tend to be thinner and also much more likely to die. So this, these confused results ended up, leading to a different conclusion than otherwise intended. So when you are looking at a study and then they're making a claim, you need to see, well, does one cause the other, or is it just a relationship because of some underlying cause, right? So that is basically the gist of what you need to do to determine that, when you're looking at studies. All right, that is it, guys. I hope you learned something and took something from the video, and I will see you in the next one.